So this is an example video to go along with my lesson video for volume on cylindrical shells. In this video, I'm going to go through this example. So this looks like a piecewise function. So I've got this function g of x. So this is sine of x over x when x is between 0 and pi. And then at 0, this equals 1. So just think about, like, why does this need to be this type of function? So if I plug 0 into this, right, then I'm going to get undefined, right, because we have 0 in the denominator. So, like, this is a piecewise function, but this isn't like a crazy, like, two totally different curves thing, right? It's just filling in a point. Okay. So I think this problem's kind of interesting because it leads you through the trick to solve it. So it starts with this part A that says, show that x times g of x equals sine of x. Okay, so let's just follow the math of how to do this. So this is part A. So I want to take x times g of x. Okay, so what I'm going to do then is I'm just going to draw my piecewise function, and I'm just going to multiply each piece by that. So I have x times sine of x over x, and then I have x times 1. So I've literally just gone through and taken the pieces. So maybe you feel awkward doing that, but that's literally what we're being asked to do here. Okay, so in this case, now I can see these x's drop out. So that's getting me to exactly what this wanted, right? Sine of x. So, okay, the top function is actually the easier one. We have it equals sine of x. So now I just have to think through, so this x times 1. So this is when x equals 0. So if I take this, so x times 1 at x equals 0, so what do I have? This is just 0 times 1, so this equals 0. Okay, now what is sine of 0? Sine of 0 equals 0. So I could actually say that this right here is equivalent to sine of 0, or sine of x. So, and on this particular line, right, it's just saying when x equals 0. So let's summarize then, what does all of this equal? Now I can kind of rewrite both of these lines, so maybe I'll just kind of erase. So now we already showed this top part definitely equals sine of x, and then this equals also sine of x at x equals 0. So this line really means sine of 0. Okay, so we've proven this part. We've proven that x times g of x, no matter what, will equal sine of x for all values on this interval. So that's all we were asked to do. And okay, I don't know why we need that, but it must come in handy in a minute. So let's move on to part B. So I'll clear some space. Okay, so next we want to find the volume of the solid that's being generated from this curve to the x-axis. So we need to sketch that, right? So here's, let me change my color. Okay, so at 0, I have the point 1, and then at pi, I have the point 0. So this curve just looks something like this from here to here. And now I'm going to revolve this around the y-axis. So I have something, let's see, I guess that looks like this, maybe going around. Okay, so we want to find the volume, and this is using cylindrical shells. So that's the method that we're going to want to adhere to. Okay, so what's the formula for cylindrical shells? So in general, it's 2 pi, and then we've got the shell radius and the shell height. And since we're revolving around the y-axis, this is in terms of dx. Okay, so we're revolving around the y-axis, and then just from the way that this particular object is being rotated, the height is entirely dictated by this curve. So I can actually restate some of this right here. So let's see. So this is going from 0 to pi. I've got 2 pi. Okay, so to get to my shell radius, I always just take x minus the line that we're revolving around, which is just y equals 0. So I'll just take x minus 0. And then, oops, and then the shell height, so that's just going to be dictated by our function g of x. So look at what I'm actually left with now, and now this actually makes sense as to why we had part A. So I get to x times g of x, and you know, when you start this problem, you're kind of like nervous, right? Because it's a piecewise function. So it's like, oh man, how am I going to integrate with this? This feels so weird. But part A actually gave us a shortcut. Check it out. I've got x times g of x, right? And I know what x times g of x equals. I can just rewrite that part as sine. So let me clear a little space, I guess. And now this is just 2 pi times sine of x dx. So this is actually a pretty simple integral once you kind of sort out what this part means. So it looks like it's going to be really confusing, but it simplifies to something nice. And so then from there, so this just becomes 2 pi negative cosine x, and so then I just plug this in from 0 to pi. So if I write this out, so now I get negative cosine of pi minus negative cosine of 0. And so when all is said and done, that's going to give me 2 pi times 2, so that equals 4 pi. So that would be the answer. Okay, so that's it for that one. So I've got a couple more example videos, so be sure to check those out. I'll catch you guys in another video. Thank you for watching.